Okay, y'all, this unit is going to be over right triangles, and we are going to be doing a lot of simplifying radicals, which are really just square roots. And so before we get into the Pythagorean theorem that this unit actually starts with, we are going to do a radicals review, and it's really important that you know how to do this going into the rest of the stuff this unit, because you're going to be doing a lot of simplifying. And so I'm going to go over a lot of these with you now before we get into Pythagorean theorem. And you'll do a lot of the simplifying with Pythagorean theorem, and then we'll do a lot more of the dividing of radicals starting the next class. But I'm just going to go ahead and do a review over all of it, which you should have learned in Algebra 1, but we need a review over it. So I'm going to do these ones that are on the front page of your notes. Okay, and so the first thing that we're going to look at is the square root of 8. Okay, and so what's important here is that you know what we're looking for. So within this 8, since it is underneath the radical, we're looking to simplify it. And so we need to look for perfect squares that go into 8. So let's just review what our perfect squares are. So really the first perfect square is 1, right? Okay, because 1 times 1 is 1. But 1's not going to help us, because if we divide something by 1, that number is going to stay the same. And so the next perfect square would be 4. So if you need to write these down to have something to look back at, then do it. So we have 4 because that's 2 times 2. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. And 10 times 10 is 100. And we could, we could keep going forever and ever. But those are the main ones that you're going to see. And so you're going to want to have a good idea of those. And so here we're going to start with the square root of 8. And it's important that we always look for the biggest perfect square within this number. And so I'll show you a trick here in the calculator here in a minute just to remind you of how we can do that, but I don't think we need the trick to figure out the factors that go into 8. So the only thing that goes into 8 is 1 and 8 and 2 and 4. So I'm looking for the biggest perfect square out of those numbers, which would be 4. So this is going to break down into 4 times 2. I'm going to circle my perfect square. And technically, and we don't ever really show this step, but because these are both underneath the square root, it's like I'm taking the square root of both of these. But I circle the one that I know the square root of. I know the square root of 4, so I always just mark it out. And the square root of 4 is 2, and then I'm left with the square root of 2. And what you can do is you can type in your calculator the square root of 8. Okay, if you don't have a calculator, make sure you get one now. Okay, so the square root of 8 is like 2.8 something. And then if you type in 2 square root of 2, it has to say the same thing, 2.8 whatever. So if it's a question, like if it's a word problem, sometimes we'll ask you to round to the nearest number or whatever. Then you could just type it in and do that. But most of the time we're going to be asking for the simplified radical, which would be 2 square root of 2. Okay. So the next one is the square root of 45. Now 45 is a number, a lot of us probably know the factors that go into this. But if you don't, the trick is you're going to go to your y equals. So type in your y equals in your calculator, hit the button. You're going to do 45 divided by x, and then you pull up your table. Okay, and in your table it's going to show you everything that multiplies together to be 45. So it's going to say 0, and then it's going to say error, because 0 times nothing is 45. It's going to say 1 and 45. It's going to say 2 and 27.5. And we want to look down this table in both columns, because you don't want to just scroll forever in the x's if you can see it in the y's. So look down the y column or the x column and figure out what the biggest perfect square is. And you're going to see that it's 5 times 9. We use this a lot too when we do factoring because it helps you get factors. but it's a really good trick to know. So here I'm going to circle my perfect square, which is 9. The square root of 9 is 3, so I'm going to bring that out, and that leaves me with the square root of 5 that I don't know. Again, I can check this. I can type in the square root of 45, type in 3 square root of 5, and they have to be equal. Okay, the next one is the square root of 12, and for some reason I put the square root of 12 3 times. I'm not sure why. So I'm going to make another one up besides square root of 12 here in a minute. But with this 12, and if you want to try this one yourself and pause the video, then do that. So here I'm going to simplify this into 4 times 3. I'm going to circle my perfect square, which is 4. I'm going to bring a 2 out from the 4, and I'm left with the square root of 3. Okay, again, you can check that. Type in square root of 12. Type in 2 square root of 3, and they need to match. Okay, the next one, and this isn't on your paper, but instead of square root of 12 and number 4, change it to square root of 72. Okay, so square root of 72. Okay, and we need to find the biggest perfect square here. So if you need to go to your y equals, type in 72 divided by x, and then you're going to pull up your table. And in your table, you're going to see all these numbers. And so we want the biggest perfect square. So a lot of us, our first thought is going to be 8 times 9. And what you have to be careful of is if we chose 9 here, there's still perfect squares in 8, which means 9 is not the biggest perfect square. So there's something bigger. I don't want to use those because that's not going to be the most simplified way. But if you look at 2 times 36, that'll get us our answer. So 2 and 36, I'm going to circle my perfect square. I'm going to bring a 6 out from the 36, and I'm left with square root of 2. And again, we could check that. Okay, now we're going to go on to number 6. So 5 square root of 18. So now we're getting into the types where we already have a number on the outside. So just a quick review over that. Remember the point of this is that we want to simplify these radicals. So I'm going to look at this 18 and say, what is the biggest perfect square in 18? Okay, that's pretty easy. It's 9 times 2. So again, I'm going to circle my perfect square. I'm going to bring a 3 out from the 9, but when I bring a 3 out, and I already have a 5 out here, I'm going to multiply. Okay, so when you bring a number out, and you already have a number out there, you're going to multiply those. And so that's going to be 5 times 3, which is 15, and I'm left with root 2. Again, you can check this. So, whoa. So you can type in this original, you can type in what you got, and they need to match. So if you weren't sure if it was 15 square root of 2, or maybe if you added those to get 8 square root of 2, just type them both in and see which one matches up with your original. And you would see 8 square root of 2 does not match up. It's just an easy way to check. Okay, the next one is square root of 5 times square root of 3. Okay, and so the rule for multiplying is going to be outside times outside. So if I had anything on the outside times anything on the outside, I'm going to multiply those together. Okay, and then trying to change my color here and I don't know how. There we go. And then I would do inside times inside. So outside times outside, inside times inside. It's just here I don't have anything on the outside. It's just a 1 that you can't see. So 1 times 1 is just 1. I don't need that. And then square root of 5 times square root of 3 would be square root of 15. The only other thing you need to check for here is if that 15 can be simplified at all. But there's not any perfect squares in 15. And so that would be your answer. Okay, number 8. I have 2 square root of 8 times square root of 18. Now this is actually a problem that if I were to give you this right now, there should be nobody that misses this. Even if you don't know how to work radicals. Because if you type this entire thing in the calculator, it gives you a whole number, which means you can't miss it. You can't simplify it wrong. But if we're going to use the rules of multiplying, I'm going to have 2 times 1, which is 2. And then 8 times 18 is 144. Okay, now you have to be careful here, and this is one of the big reasons that you need to understand your perfect squares, is that if this number underneath the radical right now, if it's already a perfect square, then you just need to take the square root of it. So what is the square root of 144? The square root of 144 is 12. Not square root of 12. The square root of 144 is just 12. So now I have 2 times 12, which is 24. I could give you another quick example of that. If I had like 3 square root of 64, okay, well the square root of 64 is 8, and 3 times 8 would be 24. Okay, it's not always 24, those both just happen to be 24. Okay, so the next one, number 9, I have 2 root 13 times 6 root 5. Okay, and so again, you just do your multiply rules here. So outside times outside is 12. Inside times inside is the square root of 65. And then you just look to see if 65 can be broken down or not, and it cannot. So that is your answer. Okay, so those are just kind of your simple, like simplifying and multiplying examples. Now we're going to look at some dividing. And so you're going to hear me use a word when we're talking about dividing, and it's going to be called rationalize. And so make sure you pay attention to when I'm using this word of rationalize and that you understand what it means. And so one of the big rules of radicals is you can have no square roots in denominator. So you know square roots in the denominator. And so to get rid of square roots in the denominator, we do something called rationalizing. And it says this on your paper. It says rationalize the denominator when necessary. Okay, you cannot have radicals in the denominator. And so what we are going to do is we're going to get rid of it. Okay, so this square root of 2 that is in the denominator right now, I cannot leave my answer this way. So even though the 2 can't be broken down, I cannot leave it this way. So we are going to rationalize it. And this is something that I know a lot of us need a big review on from last year. So to do that, whatever is in the denominator, I'm going to multiply it by that over itself. Okay, the reason I can do this is because if I do square root of 2 over square root of 2, anything divided by itself is just 1. So really, I'm just multiplying this whole thing by 1. And I'm not really changing anything about it. Okay, I'm just trying to get the radical out of the denominator. And so now, you got to make sure you remember how to multiply two fractions. Okay, we just came off of a unit where we did a lot of cross multiplying, and so it'd be really easy to make that mistake. We cross multiply when we have an equal sign in between. Okay, here I don't have an equal sign in between. I just have two fractions. So I multiply straight across. Okay, so up top I'm going to have 5 square root of 2. I'm just throwing those together. I cannot actually multiply those because one's on the outside, one's on the inside. And then on the bottom, I have square root of 2 times square root of 2. Now, if we use our rules of multiplying, that would be square root of 4. But what is the square root of 4? The square root of 4 is 2. So any square root times itself is just going to be that number underneath. So square root of 2 times square root of 2 is 2. If I asked you, what is the square root of 1,000 times the square root of 1,000? The answer to that is 1,000. Like, there is no more square root. Okay, if I said the square root of 5 times the square root of 5, that equals 5. So you're going to want to know that because that's going to save you a lot of time when you're working through these types of problems. Okay, and so now I just need to look at this and I need to check. So just 5 over 2, do these numbers on the outside, do those simplify anymore? Because that says 5 divided by 2. Okay, those don't simplify anymore. And then I need to look at this 2 under the radical and say, does it simplify anymore? And if it doesn't, then that's just your answer. So 5 square root of 2 over 2. Okay. The next one is 4 over the square root of 8. Okay, now we have a couple of problems here because not only is there a radical in the denominator, but the square root of 8 can be simplified. Okay, I would advise you to rationalize it first. Don't try to simplify the 8 yet, because you may be causing yourself more work at the end. Okay, so what I'm going to do is I'm going to rationalize this. That means to get the square root out of the denominator. So I'm going to say square root of 8 over the square root of 8, and that's going to get rid of it. So I'm going to multiply across. So up top, I'm going to have 4 square root of 8 over the bottom is square root of 8 times square root of 8, which is going to be 8. Now again, there's a couple different ways I can go from here. Okay, 4 over 8 in the front, I could simplify that. The problem is there may be a chance you have to simplify it again. So I would just save that step for the end. But I do need to simplify this 8. So 8 can be broken down into 4 times 2. I'm going to circle my 4. I'm going to bring a 2 out from that. And I need to multiply that with the 4 that's already out there. So again, I'm bringing a 2 out. I already have a 4 out there, and I'm going to multiply those. So that is now going to be 8. I'm left with square root of 2 over 8. And now I just need to check to see if this can be simplified. And it can, because these numbers on the outside. Notice that I always put my denominator under that number. That way it's easy for me to tell if they can be simplified or not. And 8 over 8 does simplify because that's just 1. And so our answer here is just square root of 2. Okay. The next one. So square root of 27 over 3. So notice here that we do not have a square root in the denominator. So we actually do not need to rationalize this because there's nothing wrong with the denominator. But we do need to simplify this 27. Okay, so the biggest perfect square in 27 is 9. So I'm going to have 9 times 3. I'm going to bring a 3 out from the 9. So I have 3. I'm left with square root of 3, and that's going to be over 3. And so now I want to look to see if anything can be simplified. And again, I like to line up these numbers so I can easily see if they can go down anymore. And 3 divided by 3 is 1. So all I'm left with is the square root of 3. It's not always going to be 1 on the outside. That's just been the case on the last couple. Okay, the next one is 12 over square root of 3. Okay, and so I do have that square root in the denominator again. So I need to rationalize this. So I'm going to multiply it by the square root of 3 over the square root of 3. Okay, so that's going to give me 12 square root of 3. And then on the bottom, remember the trick. Any square root times itself is going to just be that number underneath. So square root of 3 times square root of 3 is 3. Okay, and then when I simplify this, 12 divided by 3 is 4. So that's 4 square root 3. Okay, we're just going to do one more. We'll just do number 14, and then we'll move on to the Pythagorean theorem stuff. So, and this probably takes longer than that does. So we have square root of 5. Whoa. Alright, so we have square root of 5 over square root of 4. Now, there's a couple of things we can do from here. Okay, first of all, I could rationalize it. I could multiply this by square root of 4 over square root of 4. But that's more work than I have to do here. Because what is the square root of 4? The square root of 4 is 2. So I have the square root of 5 over 2. And all now I need to ask myself is, okay, does 5 go down anymore? And it doesn't. So that's my answer. Okay, so now what I want you to do is your notes are kind of backwards, and so you actually need to flip to the very back page in your packet. Just flip your packet over, and you're starting at the back. Okay, because, I don't know, I stapled them wrong, I guess. Okay, you just need to find the slide that talks about, that looks like this. Okay, so we're going to be talking about right triangles a lot this unit. And today we're going to start with Pythagorean theorem, which is good because that's a lot of y'all know Pythagorean theorem already. Okay, so it's important to know the different sides of these triangles. So I think a lot of you know that the longest side, remember this is the longest side, it can be found across from your right angle, which is really important when you have triangles that are kind of flipped around and it's hard to tell where the hypotenuse is. You can find it across from the right angle. Okay, so that is going to be your hypotenuse. Okay, and then these other two pieces here, we're going to call those our legs. Okay, and it's important to know the Pythagorean theorem, so it's a squared plus b squared equals c squared. Okay, and it doesn't matter which leg is a or b, but it's important that your c is your hypotenuse. Okay, like when you do your homework later, sometimes it's going to give you a and b, sometimes it's going to give you a and c, sometimes it's going to give you b and c, so you've got to be aware of that, make sure that you're plugging things in the right place. Okay, so we're going to do this first example, and we're not going to do the second one. So this first example says, find the value of x. Okay, so I'm just going to label my triangle A, B, C. And I'm going to plug this in. So I've got 3 squared plus 7 squared equals c squared. And y'all, I know a lot of this you can do in your head. I'm okay with you going straight to 9 plus 49. But I do not want you doing this entire thing in your calculator. Okay, I will be looking to make sure that you have work anytime you do Pythagorean theorem, because it is really easy to do one really silly thing wrong. So please make sure you're showing work. So 9 plus 49 is 58 equals c squared. Now we need to get that squared off of the c. So I'm going to take the square root. And then I'm going to look to see if there's any perfect squares in 58, because I cannot leave it that way if there are. And I cannot put a decimal. So the square root of 58 cannot be broken down anymore. And so x is just the square root of 58. And of course I could check that too if I wanted to. Okay, this next example, example 3, is what I'm jumping to. Okay, notice here we have this trapezoid looking thing, and we need to find x. Well, notice x is like a hypotenuse if I were to draw in a vertical line right here. Okay, well, I know the height of that vertical line is 8 because it matches up with this side across from it. Okay, and then I look at where the 5 is. I know that this piece across from it is 5, and I know that whole piece down there is 11, which means the piece that is missing would be 6 right here. And now I can find x because I have these two legs of this right triangle. So I'm going to have 8 squared plus 6 squared equals x squared. So that's going to be 64 plus 36 equals x squared. So that's 100 equals x squared. This is a nice, neat one. So I'm going to take the square root, and the square root of 100 is 10. Okay, example number 4, we're going to look at these actually a lot more next time, because this is a special triangle that we're going to see inside of here. But for now, we're going to use Pythagorean theorem. So notice, this is a square, because they're showing us all the pieces are the same. So if one leg is x, then the other leg is x. And now I'm just going to plug this into Pythagorean theorem. So I'm going to have x squared plus x squared equals. Now here's where you have to be very careful, and I will make sure that I remind y'all of this probably every day, this unit, of this very long unit. That when you square this next part, which this is considered to be your diagonal here, okay, it's your hypotenuse, but it's also called a diagonal. When you square that, you have got to make sure you put parentheses around that. Because if you want to check this in the calculator, which we do, if you type it in without the parentheses, it's going to give you the wrong number. Okay, so what we have now is 1x squared plus 1x squared. So that's 2x squareds. Okay, now if I expand this, if you square something, it's times itself. So that's like 5 squared of 2 times 5 squared of 2. I want to make sure I do this like this, and then I will check it. And so what we need to do here is outside times outside. So 5 times 5 is 25. Times inside times inside. So square root of 2 times square root of 2 is 2. Okay, and now I have 25 times 2, which is 50. So if you would have typed this in the calculator originally, it would have told you it was 50, and that's why. So make sure you know how to do that. There's one on the test that gets missed a lot like that. Now we're going to divide by 2 to knock that big 2 off. So I have x squared equals 25. I'm going to take the square root, and that's x equals 5. Okay, this next slide, and you're going to want to have this in front of you for your homework because there's a section that talks about Pythagorean triples, and we're never going to ask you to memorize these, but they are certain concepts that can maybe save you some time in the future. But if you do not memorize these, then you can always just use the Pythagorean theorem. And so what these Pythagorean triples are certain numbers that we know for sure are going to create right triangles. And so I know with like if 2 of the legs are 3 and 4, I know that the hypotenuse is going to be 5. Or if I know that the legs are 8 and 15, I know that the hypotenuse is 17. If the legs are 5 and 12, I know that the hypotenuse is going to be 13. If I know the legs are 7 and 24, I know the hypotenuse is 25. And if you know these, it just saves you some time. And so what you'll see in these 4 columns is if you look at this 3, 4, 5 column, all of these other numbers are created from the 3, 4, 5. And so if I multiplied 3, 4, 5 times 2, I get 6, 8, 10. If I multiplied 3, 4, 5 times 3, I get 9, 12, 15. And so these are just certain numbers that you can recognize. So if we went back to this problem that we did on example 3, this triangle here that we were trying to get the hypotenuse of, notice here we had one leg that was 8. Whoop, I just marked it out. 8. We had one that was 8. We had one that was 6. So this was actually a 3, 4, 5 triangle because we got this side to be 10. And so if you can recognize those, it could save you some work. On your homework, I do want you showing work. But when you get to the triples section where it just says fill in the number for the triple, then you can just fill in the number. But the Pythagorean theorem ones you need to be showing work on. Okay, and so when I get here, like example 1 says, the legs of a right triangle are 3 and 4, then what is the length of the hypotenuse? Well, then that means the hypotenuse would be 5. Example 2 says, the leg and a hypotenuse of a right triangle are 24 and 26. What is the length of the other leg? Okay, so I'm going to look in this whole big chart here and figure out what x would be. And there it is. So x would be 10 from the 10, 24, 26. That's a part of the 5, 12, 13 triple. Here's what you do need to be careful of. Say that you had a triangle that was like 3, 4, and I was looking for this down here. You have got to be careful that you do not think that this is going to be 5. Okay, because the longest side needs to be the hypotenuse. Okay, and that wouldn't work there. So just be careful of that. Okay, we're just going to do 2 more slides and then we're done. And so What we're talking about here is how to classify triangles. You'll classify them as acute, obtuse, or right. But before we do that, I just need to remind you of a rule. Okay, so we've learned this rule before, but to make a triangle, and it doesn't say this, I don't think, on your notes. To make a triangle, the two smaller sides have to be greater than the third. So an example of that, could you make a triangle with 1, 2, and 4? Okay, so is 1 plus 2 greater than 4? No. So that would not even make a triangle. Okay, what about 4, 5, and 6? So is 4 plus 5 greater than 6? Yes, so that could make a triangle. Okay, we've done that on multiple tests. It was even on y'all's final exam. Okay, so that's the first part to these. The second part is going to be if it does make a triangle, then you're going to plug it into the Pythagorean theorem and you're going to compare these. And so if you plug it into the Pythagorean theorem and a squared plus b squared equals c squared, then it's going to be a right triangle. Okay? If a squared plus b squared is greater than c squared, it's going to be acute. And then if a squared plus b squared is less than c squared, it's going to be obtuse. And so what you have to be careful of here is when you see greater than, my mind goes straight to thinking that's obtuse, and it's not. Okay? If it's greater than, it's going to be acute. If it's less than, it's going to be obtuse. And so with these 4 on the bottom, we are going to decide first if they can be a triangle, and if so, we are going to classify them. Okay, and I'm going to see if I can, there we go, make that bigger. Okay. So first I'm going to say, okay, I'm going to take the two smaller sides, which are 5 and 4, and I need to decide if this is even a triangle. So is 5 plus 4 greater than 12? No, it's not. So no, this is not a triangle. Okay, so we don't even need to classify it because it's not a triangle. If we go over to B, is 6 plus 7 greater than 8? Yes. Okay, then we're going to classify it. So normally what I do when I already have the numbers written there, I just put a little 2, the little squared. This is the part that gets missed on the test. Some people forget to square these to decide, and that's how you do it. Okay, so 6 squared is 36, 7 squared is 49, and 8 squared is 64. If you add 36 and 49, that's 85. So 85 is greater than 64, and if you come up to the top, if it's greater than, if a squared plus b squared is greater than c squared, that means that this triangle is acute. Okay, so now we look at the next one. So first we have to decide if it is or isn't a triangle. Okay, so is 1 plus 3 greater than square root of 10? And it is. If you check square root of 10 in your calculator, it's like 3.16. If you add 1 plus 3, that's bigger than that. Okay, so yes, it can be a triangle. So now I'm going to square these numbers. So 1 squared is 1, plus 3 squared is 9, and 10 squared is the square root of 10 times the square root of 10 is 10. And 1 plus 9 equals 10, so this is a right triangle. And this last one, if you type all these in the calculator, it does make a triangle. So now I'm going to square all of them. Okay, well the square root of 9 times the square root of 9 is 9. The square root of 16 times the square root of 16 is 16. And the square root of 27 times the square root of 27 is 27. and 9 plus 16, that's 25, is less than 27, and less than up here, remember that said that it was going to be obtuse. Alright, last slide here, and we are done. So this says, find the length of the hypotenuse formed by the given equation. So I need to graph these 3 lines. Okay, I can't graph the first line yet because it's not in y equals. So I'm going to subtract 3x. So that's y equals negative 3x plus 4. And I'm going to come over here on my graph and I'm going to graph that. So I'm going to start at 4 on my y-axis. And then I'm going to go down 3 over 1. Just make sure that your slope here is negative and that you don't accidentally make a positive slope. Okay, so there's that line. Alright, now for y equals negative 2. So if you look at where this is y equals a number and x equals a number, we're going to think Vux Hoi here. That's what's going to help you. So if it's y equals negative 2, I'm going to go to the y-axis. I'm going to plot negative 2, and then I'm going to make a horizontal line. Okay, so there's that line. And then for x equals negative 1, I'm going to go to the x-axis. I'm going to plot negative 1, and then I'm going to draw a vertical line going through negative 1. Okay, so it's kind of hard to tell here, but what we're looking at is this triangle right here. It's created this triangle, and what we'll do with this is it's wanting us to get the hypotenuse. So I'm just going to draw over here to the right kind of what we have. If you count going along the bottom, that's going to be a distance of 3. If you count going along this left side, it's a distance of 9. And we are trying to find the hypotenuse. Okay, so I'm going to do 3 squared plus 9 squared equals x squared. So that's 9 plus 81 equals x squared. That's 90 equals x squared. And now I'm going to take the square root of that. That breaks down into 9 times 10. Okay, my perfect square is 9. So this is going to be 3 square root of 10.